Question number 36 says a light wave travels in vacuum along z-axis. Which of the following ray represent the wavefront? The ray is traveling along z-axis, then its wavefront will be in xy plane. And when the wavefront is in xy plane, then the equation of the plane would be z is equal to something constant. And look at option 1, x is c, second y is c, third is z is equal to c. Yes, the answer to this option would be the third one. Let's go to the question number 37. A parallel beam of monochromatic light of wavelength 500 nanometer passes through a slit of width 0.2 millimeter. The angular divergence in which most of the light is diffracted will be, these are the four options. Now dear students, this question is from the diffraction. A parallel beam of light, as it crosses, the most of the divergence occur for the central maxima. Here is minima and this is minima, and this distance is the central maxima. A sine theta is equal to plus minus lambda. So sine theta is equal to plus minus lambda by A, and the total angle theta would be equal to 2 lambda by A. So that is the divergence with angle. So theta total angle will be equal to 2, and lambda is given 500 into 10 to the power minus 9, and what is the A is given 2 into 10 to the power minus 4. I have to solve this value, and the options come to be the first option, 5 into 10 to the power minus 3 radian. So answer is 1. The question number 38 says a light of wavelength 550 nanometer is coming from a distant star. The limit of resolution of the telescope, whose objective has diameter of 2.5 meter, is nearly. So limit of resolution, the theta for spherical surface is 1.22 lambda divided by the aperture. Now 1.22, and this lambda is given 550 into 10 to the power minus 9, and this is given equal to 2.5. In radian, this is equal to 2.7 10 to the power minus 7 radian. So option number 2 is the correct option. Let's go to question number 39. Young's double slit experiment is first performed in air, then in a medium other than the air. It is found that 7th bright fringe in medium lies where the 4th dark fringe lies in the air, the refractive index. It is given that the 7th bright fringe in the medium, 7th bright, and for the bright this will be lambda capital D by small d, where the 4th dark fringe lies, and the 4th dark fringe was equal to 7 by 2 into beta. This is 7 by 2 lambda capital D by small d. Now at the same location, so 7 by 2 lambda capital D by small d is equal to 7. Lambda dash is lambda by mu into capital D by small d. Now solve this, the mu comes equal to 2. And the correct option is option number 4. Let's move to the next problem. Question number 40 says two polarites A and B are placed at their transmission axis crossed. Unpolarized light of intensity I naught is incident on the first polarite. A third polarite C is now kept in between them such that its transmission axis makes an angle 30 degree with the polarite B. The intensity of the transmitted light through the polarite B is. Now dear student, this is the case where one polarite is like this and the third polarite B is placed exactly at a right angle to this one. the transmission axis. In between, another polaroid is placed, making an angle of 30 degree with this polaroid. This is polaroid C. Now if I naught is intensity here, then from the first polaroid the intensity will become I naught by 2. Now from here to here, Malus law comes. If our intensity I1 will be equal to I naught by 2 intensity here into this angle cos square of 60 degree. Now from here the angle between C and B is 30 degrees, so this intensity will be equal to I1 into cos square 30 degree. Fill value here, the final intensity will be equal to I naught by 2 into cos square 60 into cos square of 30. And the value is I naught by 2, and this value is equal to 1 by 4, and this value is 3 by 4. And your answer is 3 I naught by 32. Look at the options. The option number 3 is 3 I naught by 32. Therefore, the correct answer is option 3rd.